Good morning. My name is Joseph Bryn. I'm the publisher of Building Digital. Welcome to the Building Digital Micro Conference on Demystifying Digital Twin. We've got a great lineup of speakers for you today. Digital twins are all the buzz in the AEC industry, but what value do digital twins offer, and how can you take your first steps towards implementation? This session lays out some practical steps that organisations can take to implement digital twins and integrate them into their current workflows. We'll hear exclusive insights from industry experts, explore a real digital twin case study, and open the floor to discussion. So to kick things off, please let me introduce our first keynote of today, which is Ibrahim Atta-Apu, who's a global digital twin lead at Atkins. So you are now free to share your screen. Over to you.
Good morning, good afternoon, good evening, depending on where you are, to everybody. As Joe mentioned, I'm Ibrahim Atta-Apu, and I'm the global digital twin lead for Atkins SNC-Lavalin. 10 minutes, which isn't a long time, but I'm going to try and hit on some of the key points on a case study, as Joe mentioned, which is the Canada Line digital twin, which is one of the main digital twin implementations that we have delivered and are still in the process of delivering. And hopefully I'll provide some insights to you all on the outcomes and lessons learned and some of the interesting things on this project. So I'll talk about the Canada Line, what it is, a little bit about intelligent O&M, which is a key factor for this Canada Line twin, the challenge that was faced by Canada Line, the twin that was developed, and finally I'm going to talk about sort of adoption, which is a very, very important aspect of implementing any technology. Brief mention about SNC-Lavalin. Atkins. We're an organization of approximately 35,000 people across the globe, across all continents, specializing in a number of sectors from transportation, water, renewables, oil and gas, sorry, not oil and gas anymore, but nuclear and power and renewables, and defense. And, we work across a number of different themes as well. So we have an O&M business, which is one of our core businesses as well. So a brief mention about who we are. And the Canada Line was actually one of our projects where we were awarded a contract in 2005 to design, build, and maintain the Canada Line, which so the build took 4 years and it entered into operation in 2009. And just a brief summary of some of the key features of the Canada Line: there are 16 stations on the line, 18.5 kilometers in length. 3 water crossings, and it's a grade of automation level 4, which means it's a fully automated light rail transit signaling system. But what's interesting about the Canada Line is it has a 99.9% service availability, which is very good and actually makes it one of the highest performing rail transits in North America. And the maintenance concession is for a period of 35 years. Approximately 150,000 passengers ride on the Canada Line on a daily basis. So the Canada Line, 99.9% availability, clearly it's a high performing line. And one of the reasons for that is it adopts a lot of what we call intelligent O&M technologies, which really support its performance. And some of these range from automated rail inspections, so on-track sort of vehicle inspections, ultrasonic inspections of the rail, to clearance authority and tracking systems, which are used for security entering the line, supporting the management of activities on the line, condition monitoring of various assets on the Canada Line, intelligent traction management, so real-time monitoring of traction, but also rolling stock, which are the trains on the line. And more recently, we're using augmented reality on the Canada Line, which is used primarily for training people. Despite being a high-performing line, there are still challenges that the Canada Line faces, predominantly with data silos. So you have different functions of the organization: operations, maintenance, engineering, planning, finance, HR, and they all have their own separate systems, and none of these systems speak together. So as you can imagine, that can create a number of operational inefficiencies for how the line should be managed and operated. And that's where the Canada Line saw an opportunity to implement a digital twin, which was used as primarily a data twin, integrating these different capabilities, different data sources across the organization to drive operational decision making. So this was the thinking behind it. And now, whilst we were in the breakout session, actually, I was prompted during the conversation, great conversation that we were having, to really clarify what type of twin we're talking about here, because there are different types of twins. And the twin we're talking about is what we call a maturity level 3 digital twin, where we're integrating graphical and non-graphical data and putting a layer of analytics on top of that. For those that aren't familiar, there's a really great paper, white paper, that was published a few years ago that talks about different maturity levels of a digital twin. And this is the digital twin that I'm talking about in this case study, level 3 enriched real-time data digital twin. I won't talk much about it now because I'll run out of time, but please, if you can, look at that at your own time. So the approach that we took to develop this digital twin was an approach which a lot of technology companies are adopting now, this agile approach of really understanding the user, understanding the benefits, where the digital twin will make a difference, which was essential. So we held a number of interviews, understood the benefits, and then shortlisted which benefits to focus on from a digital twin perspective. And these are what we call in agile sort of speak epics. We had 2 main epics, 2 main core features of a digital twin that we could see, having spoken to a number of personas, what would give them the most benefit. And the 2 epics were a maintenance insight dashboard, which merges all that data together, as talked about earlier, to drive operational decision making, and then a virtual guideway to help people to assess the track without having to go onto the track. And I've got a video here. Hopefully it plays the audio, but I have a video that I will show you of the Canada Line. Please let me know if you can hear the audio.
Line digital twin.
Yeah, got it.
Connection between
Got it.
virtual and physical assets on the railway. The twin has a number of features that deliver value to end users. Firstly, it contains an executive KPI dashboard that provides maintenance teams with insights on factors such as maintenance efficiency, effectiveness, cost, and safety. Teams can also predict forecasted maintenance costs and plan their future budgets accordingly, whilst keeping track of key maintenance interventions and decisions, like whether to maintain, refurbish, or replace an asset. Through the twin, we can obtain data on each asset in real time by utilizing sensory data from the field. This includes SCADA, signaling, maintenance, inventory, and cost data, to name a few. The twin also allows us to monitor critical assets like railway switches and get an early indication if an asset is likely to fail. Additionally, the failure prediction tool uses machine learning to estimate when a failure is most likely to occur. Finally, the Canada Line twin contains a full point cloud model of the line, allowing maintenance teams to complete virtual walkthroughs and inspections prior to visiting the track, saving significant time and costs in the process.
Thank you. So that just gives a very brief snapshot of the features on the Canada Line. And I'll briefly talk about some of the benefits that we've seen from that. So we're still in the process of measuring and monitoring these benefits, but we're expecting that it will provide up to 400,000 Canadian dollars a year in maintenance savings per annum. And this is predominantly down to supporting the team from moving from planned preventative maintenance regime to a predictive maintenance regime or risk-based maintenance regime. And this is essentially ensuring that instead of maintaining something by the book 4 times a year, they may be able to maintain it once a year. And that's what the Twin is really helping them to move towards. Also, you know, there are safety benefits of not having to go onto the track for certain activities, and the reduction in asset failures through the predictive maintenance analytics. We're able to see an improvement in the reduction in asset failures. So some of the benefits here, I'm rushing because I'm almost out of time. But one of the key thing that I wanted to really conclude with is to talk briefly about change and adoption of digital twins or any technology in an organization. You know, it's been really important to put the right measures in place to support the organization to see where it will benefit each of those personas that I talked about earlier, being able to show what difference the Twin is going to make to their job, to their, you know, what difference does it make on a daily basis. This is really key, because a risk is that you introduce such great technology and then nobody uses it. What we've done is really spent a lot of time focusing, having regular pulse checks with the Canada Line team to understand, right, this benefit, are we hitting the target for this particular benefit? Periodic meetings, monthly meetings. In fact, we have one of our monthly meetings tonight with the team in Canada, where we're looking at the benefits, seeing where we are against the target. Having a regime like this in place is absolutely critical to the successful implementation of a digital twin. And so it's not just about the technology, it's also about adoption for the end user, is what I wanted to part on. I'll pause there for any questions. Over to you, Joe.
Thank you, Ibrahim. That was a really insightful account of the Canada Line. Some fascinating stuff there, to be honest with you. Have we got some questions for Ibrahim, please?
Hello?
Yeah, we can hear you.
Yeah, I just popped in the chat there. You talked about a paper there that was very insightful at the start. Would it be possible to get a link to that paper at all?
Yeah, certainly, Dermot. Yeah, I will. I'll post that in the chat.
Cool, that'd be great, thanks. And it's great to see such forward thinking. Would you have any advice? I hear what you're saying there, and I have the same fear. You know, we're talking about doing a digital twin for our higher education campus. It's a university in the west of Ireland, and the fear is no one will use it at the end. So would you have any advice on a sort of interface for the end user? Say we have a facility management team on site that are, you know, obviously they've been there 30 years and they're set in their ways, and that's understandable. Would you have any advice from that point of view, how to get them on board?
Yeah, great question. Because we had exactly the same. We had maintenance technicians who, you know, were very set in their ways with this, and you know, essentially the model that, if my screen is still showing, the model that we shown here in terms of regular engagement with them, you need to bring them on the journey. You know, that's the real answer. They need to be on the journey from the beginning, from the moment you define what they want to see. It's a case of playing back to them, and literally we had to do daily, as you can see here, daily pulse checks to enroll them, and that worked. By the end of it, you know, they more initially just a few would turn up. Eventually we had quite a large volume turning up, wanting to understand, you know, are these requirements going to be which presents its own challenges in terms of features creep or scope creep. But it was good to see that level of engagement, and that this worked really well for us to answer that.
And I picked up on, you mentioned quite towards the beginning of the presentation about using AR as a training application. I was quite interested in in that, and if you could expand on that a little bit about kind of the use of AR and maybe dig down a little bit into the specifics of how that was used in terms of training, because that sounds really, really cool to me.
Yeah, so the actual use case that's been applied is they're using AR for drivers, for train drivers, and for vehicle maintenance technicians, so that you know, you can actually through a visual sort of setting, you could do a drive-through of the line on a VR sort of AR context. But there's also an AR interface for maintaining specific features. So for instance, if you wanted to replace the bearings, it would pop up on the screen, show you where the bearings are, and you can actually simulate, shows you all the different components of that activity and how to replace, you know, step one, replace this, and it showed you. So that's how it's being used, which has been very, very successful. I would have brought it on the screen, but happy to have a separate session if anyone's interested to take you through that.
Excellent. Also, just wondering how the conversation went and how the synergy was along the supply chain in terms of following digital twin and doing that, and how did you find the communication? I mean, I think Jimmy touched about it a little bit when you were answering about kind of communication between the team and kind of old-fashioned methods and all the rest of it. I just wondered if you could expand on that a little bit more as well.
Yeah, sure. So you know, there's two aspects to it. There's the interaction with the end user and the actual CAN line, and then there was our internal sort of development teams. So we worked on this with multiple teams across the world, basically. So we had you know, developers, we had solution architects, enterprise architects, you know, programmers, but also creative 3D, real-time 3D visualization experts. And the coordination there, how we managed that was through an agile approach where we took sprints for specific features of the digital twin. So if we said, right, okay, we're going to be working on the predictive maintenance analytics, we would have a sprint that comprised of our data scientist, our developer, subject matter expert from the client organization, who would work together to perform one iteration within a 2-week sprint. And then if that feature worked, great, move on to the next. Didn't work, we go back again and reiterate it until we get it working before we move on to that. And that iterative agile approach is something that has worked well. We couldn't have delivered a twin of this complexity without that approach and breaking it into those sprints. So agile project management was a key contributing factor.
Excellent. I mean, obviously it's still quite cutting edge technology and approach. And I just wondered if you could take one lesson out, if you could do one thing differently, if you had to start, start again, basically, is there something that you think, right, if we could just start again and do that differently?
Yeah, definitely. You know, always, I guess partly, you know, this you've got little control over in terms of the technology that's available to you. But I think, you know, if we'd done this again, we probably would have spent more time, invested more time in developing our tech stack for the twin, the technical elements of the twin slightly differently. Was one, and another aspect is, and I talked about this earlier in terms of that regular engagement, ensuring that you avoid scope creep with those features, because when you get developers in the same room with end users, good things can happen, but things can go out of control very quickly. And before you realize it, you're developing things which were not part of the epic that you've agreed. So managing that, you know, general good project management is fundamental to successful twin implementation.
Reeling in that blue sky thinking.
Exactly. Yeah. Because the developers are happy to work on it, you know, but it needs to be controlled.
Excellent. One final shout out for questions. Anyone got anything you want to add or contribute?
May I ask a question?
Go ahead, Manny.
Hi, Abram. Yeah,
Hi.
I'm really interested in your sort of service and maintenance sort of presentation that you did just now. I've just sort of recently stepped into a similar role myself, but quite often I find there's lots of reports and BIM data around digital twins in the planning, the design, and implementation of a build phase of a project. But do you finally see that the industry is now got mature enough to sort of look at the post-construction phase, the operation and maintenance sort of phase, and from your point of view as an expert in the field, do you think that's where we are now, or do you think FM is still lagging, let's say, in comparison to other phases of the project?
Great question, Manny. I think it's different in every region. In the UK, there's now more strides towards taking FM, and that you have things like better building information modeling, B2IM, which is really putting the end user at the front. But in other regions, it's not the case. I think we're still on that journey from that perspective, but certainly the approach that we try to take, whether we're doing design or whether we're doing technology implementation, O&M, is that end user first, defining their requirements is what we try to do. But as an industry, we're not there yet completely. No.
So, can I ask a question?
Yes, go ahead, Joe.
Yeah. So firstly, thank you for you refer that paper, and hopefully you can put a link under the chat so we can have a look. But when I have a look at your PowerPoint, that page looks like the stage 1, 2, 3. That's exactly matching with you just mentioned the BIM, the 2D, 3D, 5D. So how you think about the relationship between the current BIM platform and the digital, and how these two things can work better? That's the first question. A second question, very interesting about your last part of the machine learning. I believe is linked with very popular at the moment topic of the AI technology support the prediction of the project performance. So I would like to know a little bit more detail about how you do for the machine learning AI technology part. And it's just to ask, it's okay, you also share, I know Joe already recording this session, it's okay you also share the PowerPoint or part of your PowerPoint. If any confidential message there, you can give up as part of the PowerPoint. That's 3 things I ask. Thank you.
Okay, sure. Thank you. Some really good questions there. The third point I'll have to check, but the first 2 points, in terms of the transition BIM to digital twin, that's something that we're working extensively on. And what I would say to that is that the key to it is your data schema, data standards, and having that consistency so that it can map across to whatever digital twin use case you need. So depending on the client, some clients may need a use case in the operational phase. Some clients may be focused on use cases in the design phase, like simulations. So either way, the data structure is the most fundamental thing, and that breaks down, you can't achieve any of the other things really. And to the second point you raised with machine learning, yes, certainly we're doing a lot of work there. And again, the architecture that you apply to a digital twin depends on how efficient your machine learning algorithms will be. It's a topic on its own, so which I'm happy to have. If I'm invited to another session like this again, we can have a separate session dedicated just to machine learning and digital twins. But it's fundamental in both your questions, how you set up your information. I won't say models, but your information and data is key to enabling twin and key to enabling machine learning to utilize the twin.
Thank you so much. Looking forward to your other topic talk, and got the message, the data and the information is the key.
Is the key to it. Yeah, absolutely. Thank you.
Thank
So machine learning and digital twins next session, guys. We're going to move on. Thank you, Ibrahim, for
You're welcome.
great presentation. And yeah, really interesting. I would love to know what brilliant project you're going on to next, by the way. I'll come to that probably at the end when we do the summary. But moving on to our next keynote. Keynote number 2 is Dr. Ahmed Al-Naga, who is the Associate Director, Building Performance Improvement at LCMB. Ahmed, over to you, good self.
Thank you so much. So I'll be talking about digital twin for existing buildings from strategy to implementation. And I think one of the questions today was actually asking about that. So in the first slide, I'll be talking about, you know, the strategy and value proposition. So when to start the journey and how to start the journey of having a digital twin implementation. So I think, you know, one of the most important things that the industry needs is to tie up this digital twin implementation with their strategy, their asset management strategy, their facility management strategy, their estates management strategy. So it needs to tie up with a strategic direction from the organization. Could be energy optimization, could be improve indoor environment quality, could be monitor and cut carbon emission and improve asset life. So there are a lot of kind of use cases for digital twin, but for your specific organization, I think it is very important to see first what do I want as an organization? What's my asset management strategy within the organization for existing buildings, and which I need the digital twin to achieve. Do I need to improve efficiency and productivity of my asset management people and my occupants in the buildings? Do I look from a certain kind of very focused on the asset itself, like its total cost of ownership, optimization, reduce downtime, improve reliability of the asset? Or do I look from the asset from a very futuristic point of view? Do I need this data for digital twin to allow for artificial intelligence, machine learning, and what we call prescriptive analytics? Because digital twin itself will provide you with the data you need to do predictive analytics and condition-based maintenance. But if you would like to go a step higher and go for prescriptive analytics and using machine learning, then you need to build that within your strategy for building that digital twin. So in general here, when we talk about, you know, going for a digital twin, you know, the most important thing here is like look into your strategy. What's in your strategy? Are you know, sustainability focused? Are you cost focused? Are you productivity focused? Are you all of the above? And then you need to formulate your digital twin implementation to align with these strategic priorities that you have. The second slide here is about, you know, the transformation approach. So how then? Okay, I know now what my strategic priorities. I'm going to implement a digital twin. So what approach needs to be there? So the first one we talked about which is the strategic alignment. The second one, I think Ibrahim touched it upon a little bit, but towards the end of his presentation as well, is change management. Because change management, you know, digital twin, especially for existing buildings, and it comes with a lot of, you know, technological change, and, you know, change management here is very, very important. First, to create buy-in for people who are doing the same job the same way for 30 years. And then you come and say, oh, well, we will install some sensors here. We will create a digital model here, and we will connect them together. And we are expecting you to manage the digital twin. So it's a bit of a, you know, a threat for their experience and so on. So change management here is important to, you know, inform people, train them, let them know what's the value of digital twin for them, making their job easier, making their job better, higher quality, and then you create that buy-in in as a part of this change management program, including it needs support from senior management, put some incentives on, do some training programs and so on. And people, once they realize that it is actually good for them, they buy in and they go for it. So start by incremental progress. So don't approach a building and say, okay, I will do the most sophisticated digital twin that's in the market for my building. No, start with incremental progress. For example, start create a model and see what are the indoor environment quality parameters using IoT, for example, and then you can build up on that and integrate other use cases like space optimization, space management, occupancy management, and so on. And then you could go a step further and do energy simulations. What is my energy spend in terms of lighting and heating and cooling and so on, and do energy simulation. So yeah, you could start small and start to scale that. So after that, you create collaborative partnerships. You look into your technology supply chain and create partnerships for a long term with your technology supply chain. Following that, you do continuous improvement and feedback. Start looking into what goes wrong, what are the lessons learned, what was great to have, and then you improve and scale up your digital twin based on that. So this is the digital twin approach that I would recommend. For starting off the journey, we said we speak about use cases, and actually it is a reality now that a lot of use cases are already existing and being implemented in the market. So indoor environment quality, there are a lot of suppliers with that. Space optimization, space management, occupancy management, water management. I've done some work into automating Legionella bacteria monitoring in water systems, waste management, energy management, and net zero, like looking into what is the carbon footprint of operating that building and how to optimize them using and uprising different options for energy management, upgrade, and so on. Automated security and safety, fire safety as well, monitoring fire safety in the built environment, lifts operation performance, and then condition-based and predictive and prescriptive asset maintenance strategies, which I think Ibrahim as well was touching upon when he said, moving away from preventive maintenance and having to have these kind of periodic maintenance, periodic checks of the assets, and go to condition-based, using the data. So when this parameter exists, this is the maintenance that needs to be done. So for the technical objectives of the implementation, there are some areas when you need in every digital twin, almost every digital twin you have. So first, it needs to sense what is the parameters, what is the asset parameter that you are sensing, ability to sense different operational parameters using IoT, be it CO2, humidity, heat for a motor, pressure, air pressure around air filter in an HVAC system. So a lot of things that you need to sense there and include in your digital twin. Analysis, ability to understand the meaning of the comparison of the results. So when I get a sense data from a certain parameter, I need to understand what does it mean, and this is the analysis. And then you do also the interpretation of this parameter. So what does it mean to have 1,200 CO2? Well, it means that the ventilation is not working properly, and so on. So this kind of interpretation is also provided by the digital twin analytics aspect. The talk or connect, so connect different systems, the CAFM system, the BMS, the integrated workplace management system, and so on with your digital model. And also to be secure and to have secure data communication between all these systems. So this is a case study of a retrospective digital twin implementation. We started by using laser scanning for the building, and then we used the laser scan, the point cloud, and then the drawings to do a BIM model for the building, and then we enhanced the BIM data and the data, the asset data within that, and then we integrated that with an IoT ecosystem, and then we harvested the data in a dashboard that you see in the end here by harvesting the IoT data and also connecting with the BIM model. So I'm just conscious that the time is not giving me all the opportunity to give a lot of more details about that. But yeah, I'm happy to answer questions or talk offline about that. So in conclusion, any digital twin implementation program needs to start with the strategic direction. You need to look into the strategy and then determine the business case and the value proposition. What value am I bringing from this and what's the business case for it? And then decide on the business case that fits your strategy. So, what value that I'm bringing that it will actually be a part of my strategy, and then implement the system and ensure quality of the data being out of it, quality of the analytics, quality of the use of people, and then upskill your team and review your processes. So it's not just about technology. You need to, improve your team skills to be able to monitor the data output and use the digital twin to the optimal kind of way, and also improve your processes. Usually processes are all paper-based and manual. So you can start, automating your processes, and finally you scale up as necessary and extend your digital twin to have more use cases gradually. Well, thank you so much for that, and back to you, Joe. Thank you.
Thank you, Ahmed. Thank you. First of all, I'll open it to the floor. Have we got any questions for Ahmed, please?
Yeah, Jimmy here. I have a question.
Go ahead, Jimmy.
Yeah, I suppose back to that graphic there you showed with the CAF FM system, and then you're going into IoT. Any advice, or I know it's difficult to recommend, but the CAF FM system you used, is there any pitfalls or any blind alleys that we need to avoid?
Okay, so I think your digital twin implementation needs to be kind of driven by your CAFM system, not the other way around. Because if we look at an existing system, I think asking the client to check CAFM system because we would like to implement digital twin is something that probably not very kind of pragmatic or really kind of good direction. So most of the CAFM systems existing right now, they either have an open API or you can connect with them using communication protocols of the IoT system. So in one way or another, it needs a little bit of work first, that connection piece, but in most of the cases that I have seen, it is achievable. And if it's not achievable, then you need to switch. If you would like to do that CAFM system integration, you need to switch it. But you don't have to, because you can also harvest the data from the twin into a separate data analytics and dashboard that's not connected to the CAFM system, and then do that last bit of initiating a work request in the CAFM system manually. So there are a lot of tweaks that you could do to work around that, but it all depends on which CAFM system you use, which communication protocol you use in the IoT ecosystem, and your digital twin, and so on. I hope that answers the question.
Yeah, I suppose, is there a paper or a discussion about maybe the top 10 CAF FM systems, or where would you start researching that? Because that's something that I think we'll be doing come September, I'd say, once we get our information together, and we need to be considering it at this stage.
Yeah, I've done a lot of work in that connection between CAFM systems and IoT ecosystem and the digital twin. So yeah, probably that we could take that discussion offline, and I could provide you some insights on that, and provide you with some guidance and reports as well that could help with that.
Thank you very much. That's great. Thank you.
Excellent. Thank you, Jimmy. Have we got any other questions for Ahmed, please?
Hello, it's Joe here again.
Hi, Joe.
Yeah, hello, Ahmed. So firstly, I would like to know any more papers and guidance regarding the topic you just mentioned. So if you can share, that will be brilliant. And secondly, about your last point on your conclusion page, scale up. So currently, I understand your suggestion based on different direction, different priority, we can build up a slightly different digital twin along with the smart building. But eventually, we want to scale up, link them together. So what kind of things we need to be careful at the moment in terms of the infrastructure build, because later on we don't want to build a lot of different pieces, but actually it cannot scale up, cannot connect with each other. So that's my question.
Yes, it's a great one. Actually, to scale up, you need to have interoperability in mind. So you need to think more about what protocols that you use to make these different areas of the system talk to each other. So you have a BIM model, you have a data communication protocols for the BIM model, and how the BIM models, because it's not probably sometimes it's not just one model. There is an architectural model, there is an MEP model, and so on, and they talk through IFC. So you need to, and also the communication protocols that the IoT ecosystem that you will use, and it's an ecosystem because probably you will realize when you start working on that space that every couple of sensors they might use different communication protocols and so on. So you need to look into the interoperability for it as an ecosystem, end-to-end ecosystem, including your BIM model, your IoT ecosystem, the hubs and the data analytics platform that you use. You need to make sure that everything that you are adding to that system, on your way to scaling it up, it needs to talk with your existing building. Otherwise, you will complicate the system indefinitely, and then you will end up with several gadgets not talking to each other. So I think interoperability is very important, and also looking into the scalability of your IT infrastructure as well. So you can use data analytics platform and cloud computing platform that allows you to scale up whatever you want, either horizontally to add more sensors doing the same thing, or vertically of adding other case studies that will enhance the performance of your digital twin and increase its complexity. So yeah, these are the two first things that I would start with in scaling up, which is again the interoperability and the scalability of your IT infrastructure.
Thank you.
Excellent. Just an observation, but something very fresh in my mind, looking at a retrospective digital twin implementation, tragedies that have taken place recently. Most recent one, quite near to us in Manchester, where we're based, in Rochdale, with the tragic death of a small child due to mold inhalation. And just picking up on some of the things about obviously humidity monitoring, indoor environment monitoring. Obviously, those are things that a retrospective digital twin model would pick up on, and tragedies that would be avoided in my mind. Am I right in thinking that?
Definitely, and I think it's a good point. Not only just by getting readings for these parameters, including for example temperature, humidity, and CO2, but there are some machine learning algorithms that will take all these, including occupancy readings as well, and do some analytics, and tells you that there is a high risk of mold being here, of virus being in this space, and so on. So they are analyzing the conditions in which some certain viruses and some certain microorganisms can live in the air by using these parameters, and then these machine learning algorithms can actually analyze all these parameters and tell you, like, okay, this room or this space is in about 80% risk of having a virus infection in it, based on the condition of it and so on. So yeah, definitely it's a very important one, and it's a very forward-thinking kind of exercise as well, because it doesn't just follow the the mere readings of the parameters like temperature and humidity and so on, but it uses them all to analyze them all and give you some other insights using machine learning, and tells you that, you know, there is a risk virus, a risk of having a virus or mold or whatever in here, so that you can be even proactive in managing these risks even before it actually you know, creates some tragic accidents that like the one that you just mentioned. So yeah, definitely it's a very important use case for it.
Excellent. Thank you, Ahmed. Thank you for a great presentation. Some excellent quality insights in such a short space of time.
Thank you.
And yeah, I look forward to sharing the recording on Building Digital for people that have attended but couldn't attend as well, because that was really insightful. Thank you. Just to introduce our third and final keynote presentation of this morning's micro conference, we're honoured to have David Ross with us. David is the Partner Operations Manager at IES, who are a leading innovator of sustainable analysis technology, supporting resource efficient and healthy built environments. At least they are according to their LinkedIn profile anyway, David.
Very true, very true. Yeah, a lot of buzzwords.
So we've still got a few less people joining us there. So yes, just introduce David Ross from IES. David, over to you. You're free to share your screen.
Hi everyone, and it's an honour to be here talking to you today, representing IES. Some of you may have heard of us. We are first and foremost, we're a software developer. We're about 30 years old, and we've created building performance software that enables users to simulate and predict the performance of buildings. And this simulation engine is known as Apache. It's used throughout the world, and our users deliver around 75,000 projects per year with our software. And we estimate that's to be well over 1 million buildings have been designed and improved using our software. And that's just a selection of some of our sort of key partners and customers. Our software is used, or traditionally used, throughout the design and construction of a building. But in more recent years, we have been focusing on how we can use and leverage the software to improve buildings during operation and tackle the built environment at scale. So I guess a little bit on our digital twin solution. Our software takes a sort of physics-based approach where the fundamentals of physics are captured within the model. So a model of a building is created, and we can predict how the building's going to perform. We look at all the energy and thermal transactions that happen between the external environment, the HVAC systems, how do people use the building, the equipment within the building, and how heat transfers throughout the building. As we look into the operation of buildings and how buildings change over time, we're capturing real data from the building, and we're enhancing that with using AI and ML to fill the data gap. So one of the key issues we face is data quality, whether it's unplanned maintenance or planned maintenance. We'll have gaps in the data. It could be poorly performing sensors, but we can improve that using our platform and enhance that the real data, and then introduce that real data into this model. So these physics-enabled simulations, typically, there's a lot of assumptions that go into these. So we assume how people are going to use buildings, and we assume how the weather's going to behave, and we assume how the HVAC systems and the lighting and the equipment is going to be used. But we can use that real data to enhance these virtual models. And once we've enhanced that model, we then calibrate it to ensure that this model then behaves and responds like the real building. So lots of different digital twins or interpretations of the term digital twin out there. IES, we are all about performance digital twins. Many of you will be familiar with BIM models or BIM. These are, I guess, static models. Whilst they're updated, they are static. Our model has an engine, a simulation engine, and has a time dimension. So we can look at how the model, that the building changes over time. Now, hopefully these videos are going to work. Yeah, so these are just a couple of examples of digital twins that we can and users can create within our platform. On the left-hand side, we have an individual building with all the, again, all the rooms, the HVAC, the way the people use the building, the external climates within that model. And on the right-hand side, we have a city or an area of Limerick in Ireland, where we have built up a digital twin to look at the district as a whole, but also focused on individual buildings and how we can also share energy between buildings and districts within a city. So I guess the digital twins, what it means to IES and what it means to myself, it's decision-making confidence. They are a platform. A digital twin provides a sort of a tool for giving you real intelligent insights into an asset. First and foremost, we have to establish the baseline performance. If you don't know the baseline of your building or asset, then how can you perform it and how can you measure performance? And our platform enables users to do that, to model the existing asset as it currently is, and then start to look at how we can improve that. And it's often a balance between lots of different factors. So energy and carbon are some of the, obviously the sort of hot points at the moment, but there's other things, indoor air quality, how different parts of the building influence health and well-being, and comfort needs. Once we have this baseline model, yeah, we can simulate lots of different scenarios, whether that's things like small tweak to the controls, perhaps heating set points, cooling set points, humidity, or it could be more deep retrofit sort of measures, such as swapping out existing heat generation plant with new ones, or stripping out double glazing and swapping it for like triple glazing. And then looking at how we can decarbonize using different low carbon technologies. So it's all about decision-making confidence and de-risking investment. Some key applications for our digital twin platform, fossil fuel divestment, looking at how we can move away from fossil fuels and come up with the best low carbon fuel solution. Looking at how, so it's very easy to decarbonize a building. We can throw as much technologies as you can, but that's not the best way to do it. And no one has the budget to decarbonize a building tomorrow. It takes time. It can take tens, if not hundreds of thousands or millions of pounds to decarbonize. So we can use the digital twin to plan across throughout time, come up with a roadmap of how we can invest, employee productivity. So again, looking back to health and well-being, and perhaps space utilization, digital twin can be a sort of a virtual sandbox for testing lots of different usage patterns and profiles. We've seen a lot of asset owners looking at decanting some floors into one or two floors, and to make use of the space, and how we can simulate how that has an impact on energy or indoor air quality, etc. A couple of case studies here. So one of our, I guess, flagship projects is the University of Glasgow campus. We have a sort of living lab approach here, where the estates team, academics, and IES as well, supporting. We have this collaboration where the students are actually creating some of these models, and the estates team are using these models to improve the individual buildings in the campus as a whole, and explore likes of shared energy networks. And by using this, the academics as well, the academic part of the university, the estates team are also able to unlock some additional funding. We've also modelled the entire borough of Warrington So that's well over 90,000 buildings. It would take a long time for one person to do that, but we can use our platform. We'll have I think for this one, we had 5 or 6 different consultants feeding into this model and synchronizing this into the cloud. And this is another thing that digital twins enables, is transparency and engagement. A lot of the software and platforms that are available nowadays, you need to be have it installed on your computer or have specialists that access them, but the clients and stakeholders don't necessarily want to see that and the raw data. So we can use these to visualize a lot of the exercises and turn some data, raw data, into some meaningful information for them. An NHS project down south, we created a digital twin of the hospital. First of all, ran some analytics to look at some low-hanging fruit. So low-cost quick wins before looking at some deeper renovation measures, and these are the sort of savings we're able to identify. So payback on digital twins are usually quite low. Within a year or two, we can normally quite easily identify some major savings, and usually from things like controls and operational measures. Finally, another good one in Singapore, the NTU campus. This is one where a campus model was created, and we did this in collaboration with the university, and to identify best and worst performers, and then went down into individual buildings and explored some energy sort of shared energy networks across the campus. I'd like to then now focus on something a little different, and this is something we've created. This is a real project, but we've anonymized it for the purposes of this, where we have used the digital twins to create a decarbonisation roadmap. And here you can see we've got 3 tabs on the top. We've got the baseline building performance, we've got energy improvement measures, and then a decarbonisation sort of roadmap. So starting with the baseline performance, let's take this building to, what we've done is we've created a virtual model of this building, and we've enhanced this with real data. So again, replacing some of those assumptions with the real known figures. So let's take lighting, for example. We assume that the lighting profile during the design stage of a building, we've assumed that the lighting is going to be on perhaps 9 to 5 for an office. But if we have a sub-meter within a building collecting that data, we can replace that profile with the real profile and values. So for this building here, for this client, we've gone through this monthly calibration, right? So the dark blue here represents simulated electricity from the model, and the light blue represents the utility bill electricity. Normally we'd maybe go down to sort of hourly calibration, but for this we've gone to monthly calibration. And these metrics on the right hand side are calibration metrics, so we can get them below a certain threshold. We can safely say it's a digital twin. And what we mean by that is it's a virtual asset that behaves like the real building. Here's an example of building 3 where we've still got a bit of work to do. So the natural gas, the simulated natural gas, is far from the utility bills in January and April. So we need to go back into that model and tweak anything that's influences the heating elements of it. Moving on to this page here. So again, we've now got a digital twin that behaves like the real building. We could then start to test things with high levels of confidence that whatever the model tells us is going to happen, that will happen in real life. So take heating controls. So for this building 2, the heating set points were quite high and they didn't have any TRVs on the radiators. So we were able to model those improvements within the virtual test bed. The dark orange is baseline energy, the light orange is the improvement. And here's the operational CO2 improvement, the investment cost, and the payback period. Take, here we go, the air infiltration or the air permeability of the building was quite poor. So by sealing and draft proofing this building, we could see a CO2 reduction of 8.6 tonnes per annum. An investment cost is quite low, and probably an acceptable payback period. And then if we go to these windows, right, something that we've all seen. If we were to replace the windows in this model, in this building, it would cost £500,000 So that's material and labour, and would say a payback of about 35 years. And now you can see that without something like this decision confidence making tool, decision-making confidence tool, we would see things like that happen. Building owners investing in improvement measures without really knowing the impact. For this building, stripping out the gas-fired boilers and replacing them with water source, air source heat pumps was probably the better way to go. Finally, we can then look at implementing these different improvement measures across time. So for this client, they want to become net zero carbon by 2030, operational carbon by 2030. So we can then implement them at different years and or months, and then look at how that we can decarbonize over time. And because we have this sort of virtual test bed, we can then play tunes on that model and say, well, what happens if we were to install the solar PV maybe in July 2023 instead of down here? How would that impact carbon, costs, energy, etc.? And as we can also across time factor in how the grid's going to decarbonize or predicted to decarbonize, and how future climate scenarios are set to change the way the buildings are going to operate. So yeah, hopefully that's been insightful, but this is just some of the things that we're doing at IES.
Good stuff. Thank you, David. It was a really insightful presentation, and obviously IES, clearly an innovator in the field. Have we got any questions for David, please?
Hello, David and Joe. Just Shane Geraghty here. Can you hear me?
Yes, Shane, go ahead.
Great. Yeah, that was also very, very insightful, David. It's really impressive how the IES program has evolved since it was developed back in the 90s. Just a question, just in relation to, these are very technical, specific questions, but the two particular measures, we actually use IES as a tool for the same purpose, and there's no question about it. The question regarding windows, everyone in their building always wonders what's the easiest way I can actually save on energy costs, and windows is one of the first questions, mainly because everyone has got one in their space, and the manual shorthand calculations or the energy audit calculations that might comply with the necessary standards never quite capture how a building actually behaves throughout the year, and as your calculations demonstrated there, that the payback on a window upgrade, now without knowing the full details, it's way outside the period, the return of investment period for a lot of decision makers. So but then I see on the heat pump, it's 2.6 years, I think, which is probably I'm not quite sure if that actually takes into account changes to the system, distribution temperatures, fan coils. It does, yes.
Yeah, those costs were provided by a cost consultant who we're working closely with, and that includes stripping out existing plant or materials, includes labour and the new equipment.
Excellent, right. Well, that's so for many people, the fabric first approach is really important, but that shows there, 500,000 on windows compared to 250,000 on your heat generators. So it's a very useful tool, and the windows, just on that, did that take account, for example, of air tightness measures when the windows were going in, all those smaller details?
Yeah, exactly that. It's what I showed was, I guess, a little bit simplistic, just for the purposes of, it's more illustrative for these sort of things. But yeah, as you know, there's a lot of detail that goes on behind those, and if you're modeling replacement windows, then you of course can account for improved airtightness, etc., along with those.
Very good, very good. That's all of from me. But I do feel there that utilizing your software tool on energy upgrade products is absolutely essential for investments. Anything over a couple of €100,000 or pounds, it really it's far superior, you know, to the energy audit calculations that we see that are a snapshot in time on a design day. So good to see, and hope we see more of it in the future.
Thank you very much.
Thank you, Jimmy.
Sorry, that wasn't me, but I do have a question.
I just realised I said that. Sorry, Jimmy. It's Shane. Sorry. Thank you, Shane. Over to you, Jimmy.
Yeah, that's really interesting, really good stuff, and something I'd like to talk about with you maybe in the future. But you talked there about collaboration with universities in Glasgow, and that I'd be very interested in doing that in our campus. And could you talk a bit how that came, not how it came about, but how does that happen? In that, do you come on board at an early stage, or is it just a reach out from the university? Or
so we have relationships with about 50% of the unis across the UK and Ireland, whether it's from an academic sort of teaching purpose perspective, or actually working with the States teams. But yeah, we for the University of Glasgow, the States team, academics, and IES as the sort of technology partner, I guess, are working closely together. And whilst some of the students are using the software and the States team are using the results and outputs of those, IES are heavily involved in things like training, working with them for maybe some more of the complex and more bespoke sort of exercises. But I think it'd be worth, I've got a far more detail on this. We've got a far more detailed sort of case study in this. I could probably give you some insights into how that could look for someone like yourself.
That'd be great, yeah. And just on your IES's roadmap for the future, are you focusing more on, you know, creating content within IES, or is there a vision for linking it in with other 3D models that are out there? I suppose there's an element of duplication that, you know, people are concerned about. Yeah, so we have I guess in the past there was a perception where IES were a little bit of a closed shop, a bit like Apple, if you like. But in recent years, we've definitely been working on it and have a huge amount of interoperability between other platforms. Revit, for example, we can accept Revit models into our software to use as a starter for 10. We talk to Rhino, SketchUp, lots of other different platforms. We can also, when it comes to the data side of things, we have a data analytics tool that sits on the cloud, and we can collect data from multiple sources. So BMS, IoT sensors, AMR, utilities. We can bring all of that into one platform, as well as simulated results. So yeah, we can sort of talk to other platforms as well using Open API.
Good stuff. We have still got a little bit more time for questions, if anyone else has anything to add.
David, just a question from me. Thanks for the presentation. That was great. Just wanted to, you talked there about, you know, the open APIs for integration with other platforms. Just wanted to understand, you know, whether you're working with on other projects with data pulled extensively from the twin model that you showed in this presentation, but whether we'd be able to, you know, pull most of that data and the sort of the dashboards, the visual insights directly into another platform of ours. Have you tested that yet, or are you looking at that sort of close integration?
Yeah, we can do that quite easily. We've tried with lots of different platforms, I guess, and working with different people, but there's always nuances there. But we have a lot of in-house expertise that we can, I guess, if there's any issues, technical issues, we can overcome. But yeah, we use our data analytics platform is where we collect and organize the data, and through that we can that's where we can talk to other platforms.
Okay, I'm just thinking about, sorry, no, I was just going to say, I'm just thinking about how we can, you already have that, so how the easiest way that we can just sort of leverage it and pull that data set into existing twins is what I would like to be keen to explore. I may reach out separately to look at how we can do that.
Please do. Thank you.
Good stuff. From my perspective, David, I picked up on one of the applications of obviously the performance monitoring, employee productivity, you mentioned at the start, and also well-being. Then the digital twin of Warrington Borough. And I've been to Warrington a few times. I don't live far from Warrington, so I was just wondering if there's a community safety application there in terms of, you know, predicting antisocial behaviour, that kind of thing.
Okay. Well, funnily enough, so for Warrington, it's purely about energy and carbon, okay? But we do have, it was for the Limerick project, which I did bring up at one point. We also, there was another exercise where we were tasked at looking at socioeconomics, and there was an element of socioeconomic modelling. So one of our tools also has a socioeconomic tool, if you like, within it. And things like fuel poverty can be looked at. Now, you need some other data sets. Our platform is great at predicting, simulating energy and carbon and other things, but you would need another data set which you can overlay within our platform to then start to look at things like fuel poverty, crime rates, blah, 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 and seeing how energy or net zero carbon neighbourhoods could impact things like crime or antisocial behaviour. It's quite a niche, I guess, a niche sort of thing, but it's certainly something which can be incorporated.
Good stuff. Thank you, David. So just to conclude this morning's session and summarise, first off, this morning we heard from Ibrahim Apal, the Global Digital Twin Lead at Atkins, with an incredible project showcase of Canada Lime and a real digital twin case study showing clear cost savings, efficiency, and safety gains. Next, we heard from Dr. Ahmed Alnaga, the Associate Director, Building Performance Improvement at LCMB, talking about retrospective digital twin implementation, improving efficiency of existing assets and buildings through predictive analytics using machine learning, and a live digital twin with strategic priorities to enable change management. And finally, of course, we heard from David Ross from IES, who are a clear innovator in their field and providing a platform that's probably underpinning a lot of the digital twin use throughout the industry, and who, I might add, were the winner of, you can pay me for this later, by the way, David, were the winner of Best Technology Partner at the 2022 Building Innovation Awards. So clearly doing something right. Talking about how a performance digital twin kind of responds to behaviours and responds with a real building, and enables obviously decision-making confidence. So first of all, I'm going to say a big thank you to all today's three keynotes, and thank you to all who joined us. We will be providing the recording of the session, edited, I might add, streamlined, and publishing that on the micro conference page of Building Digital. So with that, I should draw today's session to a close. Thank you very much for joining us. And thank you again to our speakers. It was a pleasure to have you all.